Good day, everyone. Today's lesson is on right triangles and the Pythagorean theorem. Let's begin with right triangles. From our previous lesson, you have learned about the different types of triangles, and one of them is a right triangle. So, you recall that a right triangle is a triangle where one of its interior angles is a right angle, meaning that one of its interior angles measures 90 degrees. Now we have here a figure, triangle ABC, where C is our 90-degree angle, and opposite our 90-degree angle is the longest side, which is the hypotenuse, and the other shorter sides are the legs of triangle ABC. And we have angles A and B are acute angles, and in a right triangle, acute angles are complementary, meaning that the measure of angle A plus the measure of angle B is equal to 90 degrees. And always remember that. Then let's have the theorem of Pythagoras, or the Pythagorean theorem. This theorem states that in a right triangle, the sum of the squares of the length of the legs is equal to the square of its hypotenuse. So, given triangle A, B, C here, where C is a right angle, and if we are going to label our sides here, then opposite angle C, which is the 90-degree angle, is your hypotenuse, and we call it side C. We use lowercase letters. For angle A, opposite that angle is side A, and opposite angle B is side B. And if we are going to put these words into symbols, then it just says that A squared plus B squared, where A and B are your sides or the legs, is equal to C squared, which is the hypotenuse. Or you can say that C squared is equal to A squared plus B squared. And from this formula here, we can derive other formula for the other sides of your right triangle. And the Pythagorean theorem also is used to determine the ratio of the lengths of the sides of these two special triangles. You have 45, 45, 90 triangle, and it says here that in a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as the leg. So like for example here, you have, this is 45 degrees, and if you have a triangle with two of its interior angles are equal, then that triangle is isosceles triangle. So meaning these two sides here are also equal. You have here x. If, say for example, this is your, say, A, this is your B, and this is your C. By the way, square root of 2x is just the same as 2x square root of 2. You can rewrite that. This formal and easier to remember. And then If x, say for example, is 3, so this is also 3, and your hypotenuse then is square root of 2 times that of the leg, then you will have 3 square root of 2. And if you have an isosceles right triangle, then another name for this triangle is a 45-45-90 triangle. Then let's have another special right triangle, the 30-60-90 triangle. In this triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. So we have here 90, 60, so this must be 30 degrees. And I make a shadow of it because I want you to see that when you have two identical 30, 60, 90 triangle, and if you put that together, you will be able to have an equiangular or equilateral triangle. Now let's go back. Here, this is your A, this is your C, which is your hypotenuse, and this is your B. So that is what it meant by the hypotenuse is twice. Your A is equal to 1, so the hypotenuse is twice. And your B is square root of 3 times as long as the shorter leg. The shorter leg is 1 and times square root of 3, which is just equal to square root of 3. Now, if we have this figure and your XA is equal to, say this is 4. So your hypotenuse C is equal to 8. And your longer side, which is this one, can be written as x square root of 3. So this is just equal to 4 square root of 3. And remember that, especially when you answer questions in SAT practice tests or SAT test, and it involves right triangles, then you can easily answer it by just looking at the figure and remembering this statements here. Then it would be very easy for you to find the answers. Then let's have some applications here, examples. We will use the Pythagorean theorem. In the figure below, find the value of x and y. So we have here 45-90 right triangle with one of its acute angle is 45, so this means that this is also 45 degrees. So in other words, we have an isosceles right triangle or a 45-45-90 triangle. In other words, in this type of special triangle, the sides, the length of the legs are equal. Therefore, you will say that y is equal to 2. And what about the hypotenuse x? This is your hypotenuse or the longest side. The longest side is just square root of 2 times the leg, so that x is equal to square root of 2 times that of the legs, so that is equal to 2 square root of 2, and that is your x. So this is now your answer. Then let's proceed. We have another example here. You have, in the figure below, you have to find x and y. So this is a right triangle by the small square that you see here, and one of its interior angle is 60 degrees, so this must be 30 degrees. And we have a 30, 60, 90 triangle, special triangle. And in a 30, 60, 90 triangle, if this is your shorter side, or leg. This is the longer leg. And this is your hypotenuse, or so if this is A, this is your B, and this is your C. So since this is a 30, 60, 90 triangle, the hypotenuse is twice that of the shorter leg. So that is 2x. And we have the value of b, so it's not the problem. And then we use the Pythagorean theorem. C squared is equal to a squared plus b squared. Our c is 2x, so you have 2x squared is equal to x squared plus, what is your b? It's 3 squared. Simplify that, you will have 4x squared is equal to x squared plus 9. So you have 3x squared is equal to 9. X squared is equal to 3. Therefore, x is equal to square root of 3. And since your x is square root of 3, so you have here, and so your y is equal to 2x, which is 2 square root of 3. And this is your y. Then let's have the third example. So you have here, if you study the figure, you can see two triangles. One triangle ABD. Okay, so let's do this first. You have triangle ABD, and in triangle ABD, BD is the hypotenuse. Okay, and then so if it's the hypotenuse, therefore you can say that BD, square it, is equal to AB squared plus AD squared. So we'll just simplify that. You will have AB is square root of 7, square it, plus 3 squared, so that you will have 7 plus 9. So your BD is equal to, okay, square it, 16. So BD is equal to 4. In other words, this is 4 here. And then for your triangle, you have triangle BDC. BC is the hypotenuse, right? And BC is equal to x, so that we'll find the value of x. X squared is equal to 3 squared plus 4 squared. And so x squared is equal to 9 plus 16. X squared is 25. Therefore, x is equal to 5. And this is now your answer. Then let's have some exercises here for you to answer. You have exercise 1. Do the following: form a right triangle. So you have here, and use the Pythagorean theorem. C squared is equal to A squared plus B squared, where your C is the hypotenuse, or say, I will not use the word hypotenuse here. We will just use C is the longest side, so that easy for you. And then A and B here will be the shorter side. Okay, and if they are equal, if you get it equal, then you have a right triangle. If not, then they are, the triangle that is shown here is not a right triangle. Okay, so you have 4 numbers for that, and then you will have the application of the Pythagorean theorem. Okay, this one, and then the other one here. So I want you to answer that in your notebook, and I will collect your notebook next week. That's the end of our lesson. Thank you very much. This is your teacher, Christina. Have